Okay, this is lesson 3B.3, and today we're covering rhombus and square, rhombi and squares. So first we're just going to look over the properties of a rhombi. A lot of things they're going to share with parallelograms and rectangles, but there are a few differences that we'll discuss here. So first thing that they do share is opposite sides are parallel. I'm just going to put op on these. And then that's the symbol for parallel. I'm just going to mark each of these things on the picture as I go. So opposite sides are parallel. We show parallel with the arrows. They can be in the middle. I just know that I'm going to mark congruent parts later, so I kind of put them to the side. So AB, I'm going to write this to the side as well. Or I might write it, I'll write it underneath here. Hopefully we'll have room. So AB segment or side is parallel to DC. And also AD is parallel to BC. Okay, so I have those marked and then written out here of what that is telling us. All right, all sides on a rhombi are congruent, so that's what makes it a little different than a rectangle or parallelogram. Okay, so I'm going to flip over here and mark this. So I could say AB congruent to BC, congruent to DC, which is congruent to AD. So all the sides are congruent. So I have those marked and written out. Okay. Third thing, opposite angles. That's our angle symbol. Are congruent. So a rhombi, they are not, or a rhombus, they are not all congruent, but the opposite ones are. So let's show that on our picture. So that would be angle A, and I can just use one letter here since there's only one angle at that point, is congruent to angle C. And angle B, I'm going to put 2 on that, is congruent to angle D. Okay, consecutive angles are supplementary. And in case you don't remember that, that means they add to 180 degrees. All right, there's really not a way to mark this on our picture, but I'm just going to write it out in kind of an equation here, like you would do if you were doing a proof or something. So in this case, I could say like angle, and there's a lot of options here. I'm just going to put a couple. Like angle A is consecutive to angle B. So angle A plus angle B equals 180. Or I could say angle A plus angle D equals 180. All right, next thing is we're going to focus on our diagonals. So I'm going to go ahead and draw those in on the picture. So the diagonals, remember, just going to basically cut across your picture and sort of connect the opposite angles. So a lot of times they're drawn with dashed lines like this because it's not an actual side. It's just if you were to cut that across. That last one's real crooked. Let me fix that. Okay, so those would be our diagonals. So a few things, like I said, the diagonals are going to do. First thing is diagonals are perpendicular, and that is the symbol. And if you remember, perpendicular means they form a 90-degree angle where they cross at. So means it really means all 4 of these angles here are 90, okay? One way I could write that out in a statement is I could say, like, for example, this diagonal here would be called AC. So I could say AC is perpendicular using my symbol to, and then this diagonal is BD or DB, either way. Okay, and that's really the only way to state that. Okay, next one is diagonals. I'm going to shorten that. Bisect each other. So basically what that means is they cut each other in half. So the important part for that is then it's going to create these congruent pieces. Now, the key thing here that sometimes gets messed up. So let's look here. AC, let me do that in. AC is cutting DB in half. All right, so that means that, oops, and this is really hard to show since it's getting a little complicated here, but it means to this point here, and sometimes that will be named like E or whatever. Well, we can name that for the sake of this. That means that DE is congruent to EB because AC cut it in half. Okay, it's harder to tell on those diagonals. And you notice that I put 2 lines of the markings because I've already used the 1 on the outside congruent sides. So that's one part of it, is I could say DE is congruent to EB. And then I can also do the other one. So AE is congruent to EC. All right, and then the last thing for the diagonals is they bisect the angles. And if it helps you, you can say like the angles that they touch or something like that. Okay, so this again gets a little complicated in here with all the lines. So I'm going to show it here with green. So it means that this big angle A is kind of the main angle there. Well, when this diagonal cuts in here, it's splitting angle A into 2 halves. So that means this side is congruent to this side. I'm only going to show this on one angle so it doesn't get too complicated looking. But I would want to name that using 3 letters now since it's not the only angle that's in there. So I would say angle, like I could call this little section here BAE. Oops. And that is congruent to angle, I would want to name this DAE. Okay, I could do that with each side, like I could do it right here and here. Those are congruent. But again, it'll get complicated to draw all that in, so I'm just trying to show you what we're talking about there. Okay. All right, so those are all the properties for rhombi that we're going to use to kind of start solving some of these problems below. So number 1 is a rhombus. Find the specified measures. Okay, so easiest part I would say to start with is we know that these diagonals where they intersect at, they are perpendicular, so they form 90-degree angles. So that means that angle 8 is 90. Okay, and it's really important to write this stuff in as you go. So that's 90, and if you knew that, then like if you know the symbols means 90, you don't have to write it, but I'm just kind of showing you where I'm getting that from. All right, next thing to go to is you don't have a lot on here, so you have to look at what you have. And we do have a triangle, like a rhombus. A rhombus basically is split into 4 triangles once it has the diagonals, which we're going to use a lot. So if I have this triangle that I'm looking at, I already have 2 of the angles. I have 90 and 38, so to find angle 7, I can do 90 plus 38, okay, and then I'm just going to take that from 180. Oh, that was 128, sorry. And then if I take 180 minus 128, that gives you 52. Okay, so then angle 7 is 52. And like I said, try to write it in as you go so you can just kind of see what you have left to fill in. Otherwise, sometimes it gets confusing. Okay, I would say the next easiest one to find is either 3 or 6. So I want you to take a minute here, pause the video, and try to look at your properties from that we went over and see if you can figure out a few more here, or maybe all of them. Okay, hopefully you're checking your answers here. So for angle 3, I got that it was 38, and angle 6, I got 52, because I knew if this exterior or this corner here was bisected, those two halves were going to be congruent. All right, the next part should be really quick. Basically, you know that this angle is congruent to this angle, and then they're both bisected, so all 4 of those halves have to be congruent. So 1 and 2 are going to be congruent to these down here, okay? So I can go ahead and write 1 is going to be 52, 2 is 52, and then the same thing going on here with 4 and 5 is congruent to this opposite angle here. So 38, 38. All right, if MNOP is a rhombus, find MP. So on these, we're starting to use, okay, set the equation, solve, and then plug in if you need. So property used here on the bottom, you're going to use one of these properties that we outlined up here. So you want to think about what's helping you to initially write that equation, and then if you need to use any other properties to solve. So, all right, they give us 2 sides, and on a rhombus we know all 4 of the sides are congruent. So if I have 2 congruent parts, I can simply set them equal and solve for x. So I'm going to subtract 3, add 77, okay, to do that, I would say the property I used was that all sides are congruent, and that is what you'll write, is you'll just write something like one of those. All right, in this case they actually wanted MP, which is right here, and they did not give us that, but we do know the MP is congruent to both of these, so we could plug into either of them. I would probably plug into PO just because it's a little simpler. So I'm going to do 3 times 14 plus 7. That's 42 plus 7 would give us 49. Okay, number 3, find the, remember the M just means measure, so find the degrees of that angle. Measure of angle SUT and the measure of angle RTU. All right, so again, look here and think about what's congruent, what do we need, what can we use to solve this equation for x. So RUT is this big one, and we know that angle is bisected by the diagonal here, so that makes this angle congruent to this angle. And when I have 2 congruent parts, I can set those 2 parts equal, so I can do 10x minus 23 equal to 3x plus 19. Okay, I'll minus 3x from both sides, add 23 to both sides, and divide by 7. That gives me x equals 6. Now on this one, we are solving for 2 angles. So let's look real quick. It wants SUT. Okay, SUT is S. So if you're not sure, just follow them like that. So that's this one. Okay, well they did give us this. It's that. So angle SUT equals 3. I'm going to plug in 6 plus 19. So 18 plus 19. And that will give us angle SUT equals 37 degrees. All right, and then the other one that it wants is RTU. So that's too blue. RTU is right there. So they didn't give us that one, but we do know that this in here is 37 now. We know right here is 90. So we can get that last one by just doing all 3 angles of a triangle add up to 180. Okay, so I'm going to do 37 plus 90. You can either do like plus x equals 180 or just add them and then subtract from 180, however you prefer that, really. Okay, and that will give you x equals 53. Okay, so here we kind of used a couple things. The first property that we used was right here, and we said that those angles, we use those congruent angles from the diagonals. So that is property number 7. I do not want you to put the number, by the way, because I just kind of made up those numbers. They're not anything official. I just did it for organization, so don't use those. But so I could say the property was diagonals bisect angles, something like that. Okay. After that, we did use all angles of triangle equal 180. You could do that as well. All right. ABCD forms a rhombus. Given A is at 0.32 and B is at 0.6, find the perimeter of ABCD. So ABCD is a rhombus. So we know all the sides are congruent. First thing is we need to get this length of AB. So anytime we're trying to find length, remember we're going to use our distance formula. Okay, so the distance between the x values, 3 and 0, is 3. So I square that and add it to the distance between the y's. 2 and 6 is 4. Okay, 3 squared is 9. 4 squared is 16. Add those, you're taking the square root of 25, which is 5. All right, so if I know that AB is 5, well, since they're all congruent, I know all of these as well. And so the last thing you want to do here is just get your perimeter. So perimeter is add all the sides together. So I'm going to do 5 plus 5 plus 5 plus 5. Or you could do 4 times 5 because there are 4 sides. So that gives me a perimeter of 20. Okay, again, squares are kind of similar to rhombi, but a couple differences. So we still have that opposite sides are parallel. Okay, so that's going to make AB parallel to DC and AD parallel to BC. Okay. all sides are congruent. So I'm going to mark that right here. So in that case, I could say like AB congruent to BC, congruent to CD, and congruent to DA. So any of those can be congruent to each other. Okay, one thing that kind of sets a square apart is all of the angles are also congruent. And they're actually congruent right angles, meaning 90 degrees. So in this case, we could say, or I'm actually just going to mark them on here with 90, but if I was writing that out, I could say like angle A is congruent to angle B, congruent to angle C, congruent to angle D. Or I could say like angle A is 90 degrees. Okay, so there's a little bit extra info that kind of gives you there. Okay, you can also say consecutive angles are supplementary, or add up to 180 equal 180. So like I could say angle B plus angle C equal 180. Lots of ways you could say that, but that's one. Okay, the diagonals would be AC and DB. So diagonals of a square are congruent. Okay, so that means that AC is congruent to BD. There's not a good way to mark this because the diagonals, the middle there is kind of, will be right here, and it's just kind of hard to mark that. So we'll basically just mark it when we do the halves of the diagonals. So I'll show you that in a second. So we also, going with that, diagonals bisect each other. Okay, so this is where I can show that congruence. So they bisect each other, so AC is split, and we can name this E again, into AE, and I want to use two markings, and EC. So AE congruent to EC, and DB is also bisected, so that's going to make DE congruent to EB. All right, and last thing here is diagonals are perpendicular. So on here, I will just show that with the right angles on each of them. That was a little sloppy, but you get the idea. And you can say quite a few things there, like you could say main one is AC is perpendicular to DB, but that also allows you to kind of identify those angles as being 90 degrees. All right, so again, those are the properties we're going to use to solve down here. So it says STUV is a square with SW, and this time they didn't label it for us, so let's go ahead and write where those are, or at least just draw an arrow. SW is 2x plus 13, and WU is 8x minus 41. Actually, I'm going to write it on here. So SW 2x plus 13, and then WU 8x minus 41. And we're actually looking for VT, which is this diagonal going all the way across here. So we'll come back to that. But what we want to start off with here is, okay, what can we do with what they gave us? Well, SW and WU are the two halves of that diagonal SU. So those two parts are congruent, and that is what is important to us here. So I'm actually going to start with the property. So diagonals bisect each other. You can say diagonals bisect. So that basically means that SW is equal to UW. All right, so now to write my equation, I can do 2x plus 13 equals 8x minus 41. Minus 2x from 8, giving you 6x. Add 41 to 13, giving us 54. And then divide by 6. X equals 9. Okay, so good spot to start. I am looking for VT though. So I did not have VT, but I do know that SU is congruent to VT. So I can find SU, and that will be the same as VT. So basically you can just plug into those. So if I plug in 9, 2 times 9 plus 13, which will give us SW to equal 31. So that would be right here. You could plug into the other one too if you want. So you could do 8 times 9 minus 41. I'll just double check it. So that would be 72 minus 41. And that was WU. That is also 31. So that's here. And again, you didn't have to plug in both of those because they are congruent. So just kind of in case someone plugged into a different one. All right. To get the whole thing though, if I want to go all the way across, so think about what can I do with those to get the whole length across. Well, I would want to add those two together. So 31 plus 31 is going to give me 62, which will be that whole length across. All right, if FGHI is a square, solve for x. Okay, they did not give you very much here, but that's really all they have to give us because there's so many parts of a square that are congruent. A lot of times I can kind of just copy those over. So in this case, I have this little angle here, and that one is going to be congruent to this one. So I know one way that I could do that, and there's really a few ways you could do this, but I know that this corner angle is 90. So what I'm going to do is just copy this over onto here because those angles are bisected. So this half is congruent to this half, but together they equal 90. So you could do 14x plus 6 because I just combined these and set them equal to 90. You may realize if you think this way, 90 bisected would be 45. So you could do that. Another way I think you could have done, like you could have copied this over to here and did 14x plus 90 equals 180. So there's a lot of ways to solve this problem. So if there's one that you thought of first, solve it that way. If not, I'm going to solve the 14x plus 6 equals 90 just because I think that's usually where most students go to first. So I'm going to start with just minusing 6. So I have 14x equals 84. Divide by 14. X equals 6. So like I said, a lot of students seem to pick that one. If you thought of this first, okay, you do still get 6. If you had thought to do the triangle, you're still going to come out with 6. I don't really have room to work that one out, but you get the idea. So 2 properties that we used here, though, I do want to touch on that because you have a quiz next class and you can select more than one property. So be thinking on if you're using more than one. The first one I used was diagonals bisect the angles. And then the second one that I used was all angles, equal 90 degrees. If you use this equation, well, you really kind of got to use them for both, I guess. It's just a different order. Okay, 7 gives us absolutely nothing in terms of numbers to start with. So you just need to think, like, what do we already have? And most specifically is finding these angles. That can be where the struggle is more so sometimes than what they are. So take a minute and look where each of these are. Make sure you're being careful. So PRS. So PRS. So that's going to be this space right here. Okay, well, if this is 90, and if it helps you to go through and like mark everything that's 90, like those are all 90, these are all 90, then you can do that. That kind of helps you out. So for this angle, I want to think, all right, well, if 90 is split in half, then that would give me 45. Okay, next one is STR. So STR is right here. Well, we already have that labeled there. Is a 90 because the diagonals bisect or intersect at perpendicular or 90-degree angles. PSR. So that is here, so it's the whole thing. Okay, make sure you include the whole thing. And so that again will be 90. And then lastly, we have QPR. So QPR is just the half one here, which half of a right angle again is 45. Just got a little wonky there. All right, and 8. ABCD forms a square, so if it helps you to kind of draw that out, you can. Given A is -3, 2, and B is 2, 14, find the perimeter and area, so I'm doing both here, of ABCD. So again, we want to start off just finding what is the length of AB by using our distance formula. So AB, the x values, -3 and 2 are 5 apart. And then 2 and 14 are going to be 12 apart. Okay, so we want to total that up. So 25 plus 144 is 169, and the square root of 169 is 13. So that means AB is 13, but it's also congruent to all of the other sides. So I'm going to start with the perimeter. I can do, probably the easiest way is just do 4 times 13 because there's 4 sides and they're all going to equal the same thing. So that gives us a perimeter of 52. Okay, area, the area formula for a square, hopefully you remember, is base times height. Or you can just think like side squared. Some people, I think, use that one. Base times height, you're just multiplying that number by itself. So I'm going to do 13 times 13, or 13 squared, which actually puts us back to where we started in our distance formula, giving us 169. So again, we have 2 answers here, so make sure you're getting them both. Okay, today make sure you have your homework, but also your homework check on Canvas, all right? Make sure that is submitted along with those from lessons 1 and 2 of this unit. You do have a quiz next class, so make sure you're getting caught up and ready. If you're needing tutoring or needing something in the meantime, please just message me or see about going to tutoring after school. All right, have a good day.